C'est bon pour le streaming? I think we can start. Good afternoon, everybody. I'm Vicky Mosteirin. I'm Managing Director of Innovate Europe. You are sitting at Innovate Europe. Here in Brussels, we want to be the European network of reference of organizations working on sustainable innovation. We have some with us today. So welcome everybody to this networking event on advancing circular economy and agriculture. Today we're going to be discussing on the potential of circular economy for agricultural waste to transform agricultural byproducts into sustainable and eco-friendly products from the waste. And we're going to be looking at the technologies and the results and products of our project Unlock, which is still going on, still 6 months to go. But also we will be looking at other leading projects as Brilliant and Waste to Funk. There is also an exhibition area outside where you can see all the end products of Unlock. And we have with us Sara Montes, who is the coordinator of Unlock, and who is going to be presenting a little bit more of the project in a minute. Sara has a PhD on renewable materials engineering and more than 20 years experience on not only European projects, but all kinds of projects. And she's going to be presenting us on the technologies and the products of Unlock. So thank you. Of course, there will be occasion for networking. That's the idea at the coffee break, but also when we finish all the presentations and discussions. So welcome and thank you. Sara. Yes, the video.
Okay, good afternoon. Thank you very much for this kind introduction. Good afternoon and welcome to this networking event organized in the framework of Unlock project and hosted by Innovate Europe. Before presenting the different speakers, I would like to give you a brief introduction about the project. I don't know if we can see the of the project.
Just a second.
Well, the first question is, what is the context of Unlock project? Why Unlock? So it is estimated that around 3.6 million tons generated per year only in Europe by the poultry sector. Current management practices don't exploit the full potential of feathers as a raw material. What Unlock proposes is to generate more value for the primary sector and, on the other hand, to maximize the utilization of feathers material. So, aligned with the European strategy in circular economy, Unlock aims at creating new value chains led by the primary sector that will generate innovative bio-based products for the agricultural sector. To do so, Unlock has carried out depth analysis of the poultry sector in Europe. We have investigated in different feather treatment, and these treated feathers have been upscaled and used for the manufacturing of different end products. All this work will be shown by our presenters this afternoon. So now,
but it's not. So
no, it doesn't work. The video.
it's not working.
Too late.
It's okay. Sorry about that. Here you go. You're done?
Yeah.
Okay.
So now, we are starting with the presentation of the different speakers.
Thank you, Sarah, but we can watch the video.
No, that's necessary.
Yes. Yeah.
Unlock project is working to design environmentally and economically sustainable value chains to enable valorization of feather waste streams as a feedstock for bio-based industry. The bio-based products created will be tailored to the needs of the agriculture sector. These will include seed trays, non-woven geotextiles, mulch films and hydroponic foams. Since feathers are nearly 90% keratin, the innovative materials arising from these new value chains will be zero waste and allow for controlled biodegradability. This will ultimately enable soils to be enriched with an organic source nitrogen. Unlock will also develop new smart regional value chains that look to improve on the collection, storage and transport of feathers. The project partners are developing a comprehensive snapshot of the existing poultry feather value chains. This means measuring their technical, economic and financial feasibility and proposing optimized logistics strategies. Want to know more? Visit www.unlock-project.eu.
Thank you for the video. So now we will have Simone Macaferri, who is the project officer at the CBEU, who is going to be talking to us on the European vision for circular economy in the agri-food sector. Simone is biotechnologist by training, and he holds a European PhD in industrial microbiology and biotechnology from the University of Bologna. And after the completion of your doctoral studies, Simone worked for about 10 years as research manager in the bioeconomy sector at the Uni of Bologna. And since October 2022, you joined the Circular Bio-Based Europe Joint Undertaking as project officer. So thank you very much, Simone, for being with us today, and the floor is yours.
Thank you. Good afternoon to everybody. So I'm happy to be here as a project officer of Unlock for this event that I think is interesting to try to familiarize with the external stakeholders and other projects. The title of the presentation is probably overambitious. What I will try to do is to frame a bit how CBJU is positioning itself in the R&I scenario and emphasizing the role of primary production in the development of the bio-based sector. And also we will try to understand also how this situation is evolving, because the bioeconomy scenario is changing, and there are a number of new policy inputs that are also quite relevant with the new commission that is coming, with many important events that has been developed over the last 2 years that influenced the bio-based industry sector. So what is CBJU? Maybe not all of you are familiar with our organization. CBJU is an institutionalized partnership between the European Commission and the Bio-Based Industry Consortium. Is co-funded by the European Union and the private money by the industries affiliated to the Bio-Based Industry Consortium. The total budget of CBJU is of 2 billion euro and is a public-private initiative that is working towards general public interest, ensuring a competitive economy for the European bio-based industry, creating new jobs, and achieving the European Green Deal objective of climate and environmental neutrality, the fossilization of the European economy, and at the same time is trying to address the challenge of the industry in order to support that pathway that the industry should do in order to achieve that objectives. We are trying to de-risk private investment by funding a different type of action, and we are leveraging public funding and trigger additional investment in order to deploy projects that are really close to the market. We have a strategic research and innovation agenda that has identified the main technological and innovation challenges to be addressed in the bio-based industry scenario, and this is outlining the activities in terms of research, innovation, deployment that are meant to be achieved in the 10 years lifetime that CBJU has as Horizon. We are now not even in the middle of this pathway, and therefore there is still quite room to work together to influence what will be in the next 3-4 years to come. We are working, as you might know, with annual work programs. We are every year publishing call for proposal. We are now in a very hectic period of the year because the evaluation are going to start. Maybe some of you applied in the call for proposal 2024 that ended last September. And the call for proposal are the result of a negotiation between the Bio-Based Industry Consortium and the different European Commission services, so the different directorate that has relevance and interest for the bio-based sector. We are funding different kind of action that span from lower TRL research and innovation action to higher TRL scale up and demonstration initiatives. And what is a bit different from CBJU compared to the normal framework program cluster 6, for example, is that we fund large-scale, first-of-a-kind biorefineries that has TRL 8, so are pre-commercial scale large plants that are the ones that are really meant to go towards the market. Plus, we are funding a number of coordination and support action to create the enabling condition in order to facilitate the deployment of the result of our actions that can be capacity building, can be support to widening, can be inclusion of primary producer, and so on. So far, CBJU has funded 192 projects. Over 1,500 beneficiaries has benefited from CBJU funding from 43 countries, so much more than the Europe 27. 35% of the beneficiaries are SMEs and 25% are universities and research centers. More important, as we are a public-private partnership, every euro of public money that has been put in CBJU led to a private investment of 3.23 euro. So this is something that is quite unique and pretty important, especially in a sector that require a dynamic involvement of the private actors. This is at the stage of today the overall framework of where the flagship biorefinery, and this is also why we launched last year a CBJU widening strategies in order to support the participation of widening country and trying to expand also CBJU in widening countries. These are the flagship projects that has been funded so far. They are 19. They are covering several European countries, and they are also covering several kind of feedstock. The main feedstock for the CBJU projects are agri-food, but we have also a quite substantial number of projects dealing with the forest-based feedstock, and also an increasing amount of projects that are addressing aquatic biomasses. Then we have also bio-waste, wastewater, side stream from industries, or, for example, biogenic CO2, but these are minor feedstock compared to the primary one that are primary crops and secondary biomasses from agri-food, forest, and aquatic. The areas of application of the CBJU projects are mostly dealing with the production of bio-based chemicals and bio-based materials, packaging, construction materials, textiles, but also we have quite strong portfolio of projects dealing with food, feed, and cosmetics, or crop protection and fertilizer. So you can see that the applications are quite diverse, and also in a single project you might find a multitude of different areas of application. Why the primary sector is important? Now let's come a bit more towards the agri-food part, agricultural part of the presentation that is important in the context of today. CBJU want to strengthen and empower the primary sector, and is recognizing that only through strong involvement of the primary sector and the actor of the primary sector there is real development and results that can go to the market in a equitable and profitable situation for all. The investment in rural areas is a political priority for the Commission, and it has been such in the last years. And this is the reason why when CBJU started, taking the inheritance from the predecessor BBIJU, it started with, in the founding document, in the Council regulation that created CBJU, with a strong emphasis on the role and the importance of mobilizing and integrating primary producer in the projects. Primary producer should be included in all the action that are at ITRL in CBJU, but also many of the research and innovation action that we are funding are requiring the integration of the multi-actor approach, and therefore a strong involvement of the primary sector. In our CBJU governance, in the Council regulation has been indicated the need to have a deployment group or a working group specifically dedicated to the inclusion of the primary producer and the engagement of the primary producer in our governance. And in our strategic research agenda, it has been identified a specific KPI on the monitoring of the number of primary producers that are either feedstock producer, a supplier, or primary producer as such, that are participating to the projects. So we need to engage and integrate primary producer sustainably in the design of the research activities and innovation activities of CBJU. We have to improve the involvement of primary producer in the value chain. We have to work in order to have an empowerment of local bioeconomy actors included in the primary sector as a main outcome of our projects. And we have to oversee that the primary producers are appropriately involved in the research initiative, not only as member of the consortium, but also as external entities that are anyway really critical in the development of the tasks that are part of our projects. This is a way of adapting the concept of the multi-actor approach that the DGRI already some years ago developed into a broader context that is the context of the bio-based sector, that is different from the context of the agricultural sector, but that should benefit and cannot be disregarding the role of the primary sector. This is to give you an idea of where we stand now in relation to the KPI on strategic participation and integration of feedstock producer and supplier towards large-scale valorization of sustainable biomass. We had, for the entire CBE program, so for the all 10 years of CBE, a target at 2031 of 100 primary producers involved in our projects and 20 waste management actors involved in our projects. So far, we had 2 calls of CBJU that has been funded and project that has been awarded, and we have a cumulative number of 70 entities, 70 primary producers that have been engaged in the project that has been funded in 2022 and 2023. They are mostly, of course, dealing with the agricultural sector, but we have also a number of primary producers from the forest sector or for the aquatic sector. So we have around 70 primary producers in total that are engaged in CBJU projects with 7.5 million, about 7.5 million of CBJU funding devoted to primary producers. These numbers are also strictly linked to the main source of feedstock that the primary that the CBJU projects are using. As you see, the vast majority I was mentioning also before of feedstock are agri-food, and you see that agri-food feedstock are especially important in the flagship and in the demo. So this means that compared to other feedstock like the forest or the aquatic or the bio-waste, the agricultural feedstock are those that are more readily available for area scale up, and therefore it is where we have to look at when we think about the future policy scenario in the context of the years that we still have in front of us regarding Horizon Europe and CBJU, but also what will be the next framework program. During the last years, some policy events further fueled the importance of CBJU and the importance of working in the bio-based sector and the interface between the primary sector and the bio-based industry. Last year, the European Council endorsed some conclusion for the opportunities of bioeconomy to revitalize rural areas. And the Agri Council, when the Swedish presidency was in charge, stressed the importance of supporting the bioeconomy as a tool for rural regeneration and revitalization of the rural economy. This means that we have to work towards empowerment of the primary sector in order to avoid to have a biomass availability gap. There are several national and regional policies regarding and strategies regarding the availability and sustainability of the biomasses, and we have to work towards an harmonization of the biomass scenario in Europe in order to ensure that biomass are readily available towards their exploitation. In doing so, the mobilization of the primary producer should be emphasized, as should be emphasized the role of the bioeconomy for vibrant rural areas. And the European Council stressed the importance of sustainable solution to ensure the diversification of the incomes in the bioeconomy sector, also for primary producer. And the bioeconomy can be really what can make the difference in order to have a diversification of the income for the agricultural sector. And this was something that was also uptaken in the final report of the strategic dialogue of the future of agriculture that was published at the end of this spring. The bioeconomy should be of central importance in combating climate change, promoting ecosystem resilience, and delivering solutions that restore the nature. And in this document, it was emphasized like as a strong public-private partnership, as CBJU is, can have a strong role and should embed and actively and ensure the active participation of rural actors in order to make the development and implementation of the bioeconomy not something that is a niche area, but is the everyday norm. There is still a lot to do, but at least there is an increasing recognition of the importance of that. We are working towards the implementation of that in terms of projects. It's not easy because not always we are all aligned on the same page. Also, all the different policy DGs in the Commission, they have not all the same priorities, and they have not all the same understanding of the different nuances of how the bioeconomy is made, but we are getting there. And in order to shape the future, both of CBJU, both of the sector where you are working, but also of the framework program that is going to come, we have to work together in order to ensure that this recognition is not only on paper, but is on practice. And with that, I'm ending, and I'm thanking you for the attention.
Thank you so much, Simone. I don't know if we have time for some questions. Anybody has any question for Simone, please? Maybe later. Maybe later. Thank you. Grazie mille. Grazie. Thank you. Okay, so we go to the next presentation, which is from Daniel Trask, coming all the way from Ireland, from Farrell and Mitchell. They're consultants on the agribusiness sector, partner of the Unlock project. They've been looking to the value chain analysis. And yes, you've been working in Unlock for the last 3 years, and very excited about all the value creation and circularity potential that the project is showcasing. So, thank you.
Thank you. I might go without this if.
Yeah, you can just. Yeah.
No, do you need the
I
microphone?
need it. Okay, no problem.
Thank you.
Hello, everyone. As Vicky mentioned, I'll be speaking to you today about EU's feather-based economy and the challenges ahead through this perspective of Project Unlock. So within the project so far, we've done a lot of work around the value chain analysis. A component of this was the stakeholder engagement, where we spoke with slaughterhouses and renderers to understand their value chains, the feather management practices that they have in place, and then the challenges that they face as well. From this then, we looked at potential value chain hurdles, how some of the challenges that are facing stakeholders currently might apply to novel value chains in the future, and other potential hurdles that may exist as well. And finally then, we looked at solutions and avenues that we might be able to use to bring the novel value chains to fruition. So first off, as I mentioned, we spoke with slaughterhouses. So we actually spoke with 6 main slaughterhouses across Europe. Each of them are quite large players within the industry. As you can see, they're ranging from 34 million broilers slaughtered to 210 million each year. Typically, what we saw throughout the engagement was that they slaughter at 35 to 45 days, which would be industry standard, at 2 to 3 kilograms in weight. And typically what we would consider of this is that 4 to 5% of the weight of the broilers is in the feathers. One of the most interesting findings from this part of our research was that a lot of the stakeholders, in fact all of the stakeholders that we surveyed, recycle over 95% of the feathers that they produce. So either they render the feathers in-house or send them to rendering externally. And below at the bottom you can see that just the amount of feathers that are generated by each of these players. So as I mentioned, the key finding really was that the majority of feathers are sent to rendering for further processing. Now, whether that's because these are major players and they produce a lot of feathers, and maybe that doesn't happen as much at a smaller scale. The main challenges that they raised, obviously avian influenza is a massive disruptor for the poultry industry, so that was no surprise. Feather contamination as well was one. So when the feathers are collected at the slaughterhouses, they're typically mixed with offal and blood and other byproducts, I suppose, from the process, as well as water. And that contamination of the feathers can actually degrade the quality of the feathers. So that was a challenge that we recognized immediately would be important for Unlock as well. And then linked to this was the transport of the feathers as well. So obviously if you have feathers mixed with blood and water and other things and they're kept in a container for an extended period of time during transport, it's not going to be very pleasant at the end. And again, it's going to impact on feather quality as well. We also spoke to a range of renderers within the industry. They process various categories of animal byproducts. So the main category that we would be concerned with on Unlock is category 3. So that's basically the lowest risk materials, and feathers fall into those. We also looked at the distances that they are from the slaughterhouse in terms of the transport affecting the quality, but as well in terms of the potential environmental impact of that transport. And there's obviously quite a big distance between where these stakeholders were getting their feathers from. And then finally, we also looked at the products they produce. So feathers that go to rendering produce feather meal, and from that they can produce pet food, aquafeed, and fertilizer typically. So the challenges that were raised again here were in terms of the avian influenza, obviously as a disruptor to supply, the feather contamination, as I mentioned, impacting the quality of the feathers, and then the transport as well as the slaughterhouses mentioned. One interesting thing here was that they actually quoted a lack of raw material to us as an issue that they face. So they have quite a high demand for their end products, whether it be the feather meal or the pet food. And for them to actually get the feathers in as the raw material was proving to be a challenge for them for whatever reason. There were also bureaucracy issues that some of them noted relating to perhaps the implementation of some of the regulations surrounding the end products or transporting the raw materials across borders. So looking at Unlock's novel value chain then and the potential hurdles here, we looked at EU regulations initially. So what we saw was that there's no specific EU regulation relating to the use of feathers in bioplastics, so we thought that might be a major issue. But really, within the animal byproduct regulation, there are processes that need to be completed in order for the products to be placed on the market. So by processing the feathers in line with this regulation, the feathers can then be used in products such as the bioplastics under Unlock. Feather availability, we saw maybe a potential hurdle as well, given the fact that the renderers did say that there's strong demand there for feathers and that they really need more feathers, if anything. And then there are also maybe some impact of the diseases and that impact on supply as well. We looked at market hurdles, so obviously there's going to be competition from conventional and other bioplastics then at the end when it gets to the end product stage, and potentially some consumer acceptance as well. So whether it be just because of the fact that feathers are included in a bioplastic and that's maybe not typical of an ingredient that would be used in bioplastics, or maybe it's because people don't like that animal products are used in the bioplastics. So that's going to be a hurdle when we get to the market stage as well. We looked at logistical hurdles in terms of the transport distances, and that's again linked to the feather quality in terms of the transport of contaminated feathers. So for our processes in Unlock, it's really important that the feathers aren't degraded, because that results in the keratin itself within the feathers being degraded, and the keratin is the ingredient that we need obviously for the end products. Feather quality is a major issue, as I suppose linked to the infrastructural hurdles here as well. There's not really a lack, or there is a lack of infrastructure there to clean feathers in slaughterhouses at the moment. As I mentioned, the processes that are currently in place mix the feathers with the blood and the offal and everything else, because they're not really seen as a potential value add product. So that's something that's going to need to be addressed. And again, that's linked back to the transport in terms of if you're transporting contaminated feathers, it'll impact the quality. So looking at Unlock's value chain moving forward, then what we try to do is categorize some solutions at each stage, maybe of the value chain. So the first of these would be the feather collection point. So basically, there would need to be additional feather management processes in place in order to ensure clean and dry feathers and to ensure that feather quality then that's needed for the various processes under Unlock. Implementing these at the slaughterhouse stage would also help to reduce transport costs and emissions, as if you're not transporting water and blood and everything else that you don't need at the end, then you're obviously going to reduce the weight, and as a result, you can fit more of the material you actually want in the containers and you can reduce your emissions as well. We looked at integrated business models as perhaps a solution here as well. So that would involve locating the processes adjacent to the slaughterhouses as opposed to having to transport the feathers. This would obviously help to guarantee the supply of quality feathers into the value chain, as there's only one actor involved and they have control over the whole process. And we also looked at this in terms of reducing the distances between actors in the value chain as well, and the various benefits that would have. Renewable energy here may be a solution as well in terms of reducing the footprint of the factory operations and perhaps in future to decrease the emissions from transport as well. We then looked at the feather treatment stage. Obviously here, I suppose the high investment costs that are required, whether it be at slaughterhouse or at the feather treatment stage, to bring in the new processes, may be a barrier to entry for some. So there's potential, obviously, under certain EU grant schemes or low-cost loans for bioeconomy initiatives. We saw those as potential solutions there. We also looked at a model which has been used, I suppose, in the animal byproduct industry already, which would be a third-party model for an entity to come in to assume control of the feathers at the slaughterhouse and for them to remove, I suppose, the financial and operational burden to the existing actor in that case, and again also help to guarantee the supply of quality feathers, which is really important. We considered focused business strategies like focusing on high value creation, low volume markets initially before scaling up and not just going for high volume immediately. And then long-term agreements with suppliers as well. So if you can lock in long-term contracts, then that will help to guarantee the supply of feathers into the value chain as well. Finally, we looked at some of the market challenges and what we might be able to propose as solutions to those. So the feather keratin itself may enable Unlock products to achieve cost competitiveness. So obviously feathers, given that they're typically viewed as a waste stream at the moment, they're not really an expensive ingredient, at least before processing. So that might help us to achieve some cost competitiveness with alternative bioplastics that are available on the market. And then also in terms of product differentiation. So we can differentiate obviously from the conventional plastics through the sustainable image, whether that be because of their makeup or because of their biodegradation. And then we'd also look to differentiate from current bio-based plastics with specific product characteristics. So whether that be the tailored biodegradation timelines, altering the makeup of the bioplastics themselves to ensure that the net result is what the consumer really needs. Yeah, so that's fairly much all I had on that. So if there are any questions, I'd be happy to take them. Sure.
One second, I will give you the microphone. Is this streaming?
Actually, I have two questions. So the first one is, you said towards the end that that it's considered a waste product, but still most is being used. How?
Yeah, I suppose it's viewed as a waste product from how it's being managed at the slaughterhouses. And a lot of the slaughterhouses that we spoke to, and even after we did the stakeholder engagement to other slaughterhouses in the industry, they don't actually get anything in return for the feathers that they send to rendering, because of the fact that they're mixed with so many contaminants and that they're not really viewed at the slaughterhouse stage as a valuable product. So yeah, that's why that is.
And then my second question is related. That's I mean the 5 or 6 stakeholders that you talked to, they were all rendering their feathers, and then you said that number or it was between 95 and 100% of their feathers, and that number is probably lower for smaller
Yeah.
actors. Have you looked into that a bit more?
Well, we haven't, I suppose, categorized it exactly, but just, I suppose, as in our role as agribusiness consultants, we would have connections with slaughterhouses, and we see that in Ireland as well. Some of them do send them to rendering, and some of them just send them for waste. So it kind of depends. I suppose maybe some of them aren't aware of the potential value creation of them, or they're just not interested. But that's the situation.
Thank you.
Thank you. Okay, thank you.
Thank you, Daniel. Thank you so much. Okay, now we're going to be looking at the technologies on the feather processing and upscaling. And I have Jonna Almqvist. I hope I pronounce it well, all the way from Sweden. Jonna is a project manager at Rice Processing, also members of Innovate Europe. And the floor is yours. Jonna, thank you.
Thank you. Okay, hi everyone. My name is Jonna Almqvist, and I work at RISE. It's the Research Institutes of Sweden. And I'm here to talk to you about, should we see how to do this? More. Okay, now, I'm here to talk about the technologies in feather processing and the upscaling of them. So, in the Unlock project, we have looked mainly at 3 treatment techniques. It's the mechanical grinding, steam explosion, and microbial fermentation. And these we have looked at up to demo scale. And for the mechanical grinding, it's the Polish company Cedrob that has been doing it. For the steam explosion, it's RISE in Sweden. And for the microbial fermentation, it's bioextracts in Sweden. And we have been looking at different products for these techniques. So it's hydroponic foams, non-woven geotextiles, mulch films, and forest and seed traits that has been the goals in this project. So for starters, we're looking at the mechanical grinding that Cedrob has been working on. So Cedrob is the largest Polish meat producer, and it has been working since 1991. And in their production process, they produce 50 tons of feathers every day, which is a byproduct that requires management, as we heard Daniel talk about. So Cedrob mainly processes this into feather meal, and this can be used as feed or a fertilizer. But due to this amount of feathers, we need to look into different ways of treat this. So Cedrob has been giving other partners in this project ground feathers so we can process them further. And here is a map of where Cedrob is located in Poland. So the main task for Cedrob has been to produce treated and safe feathers that has been suitably ground for the use of the different partners in the project. And here you can see the different treatment processes that they have been using. So it involves washing it to remove dirt and grease that comes up in the poultry farming. And the next step is then to dry the feathers to evaporate the water and eliminate microorganisms. And then they have ground the feathers to the appropriate sizes for each partner. Okay, so let me see. So this process that they have, it's an innovative process, but so the right equipment had to be found. So in a laboratory scale, these small samples was pretty easy to obtain, but scaling it up to semi-industrial process, that was not easy for them. Because due to the structure, strength, and the flexibility, the crushing of the feathers caused them to heat up, and it often blocked the devices that were used. So the best results were obtained with crushing of wet feathers. And here you can see different pictures from the starting materials and when it come out of the grinding machine. So after different tests were carried out, this process was designed. And it's automated and designed to produce 200 kilos per hour of dried feathers. And this process contains of different steps. Can I do no. Okay, so it starts over there with washing and rinsing and spinning at the same time to optimize the area it will need. And then it goes through to this side to the grinder. And then it's dried, and then it's a bagging station where the material is packed. So it's a vacuum system that takes the feathers from the dryer to the bagging station. And here also foreign bodies is separated from the feathers. So here we are. So now a demonstration plant is being built in a new facility in Kutno in central Poland. And the demo plant is scheduled to be launched at the end of 2024. So this is a schedule of how it will look and where it will be. So the feathers that are obtained in the process are characterized by different parameters. So they are scanned for salmonella and different bacteria, and also for color and moisture content and how the fat content varies. And then the feathers have been transported to different partners. And the main goal for these ground feathers have been geotextiles. So this process is an alternative option for this byproduct, and it can be implemented in poultry meat production plants and making this problematic material a valuable product and an additional source of income for these companies. And conducting this process at the place of the feather production minimizes the need for their transport to rendering places. And this will reduce the carbon dioxide emissions that is associated with transportation. And the process of sanitation and milling of feathers requires less energy compared to the production of feather meal. So, and now we will go into the next technique, which is steam explosion, that I have been responsible of for rice in Sweden. So steam explosion is a thermomechanical process that is used to break down materials. This will cause cell rupture and break down the material to get out, for this instance, the keratin inside. So it works with the high pressure steam and then a rapid pressure release. And typically this process is used for lignocellulosic biomass. as wood chips or wheat straw. And for that, the goal then is to get the sugar out of those materials. So the equipment we have used is not new, but the use on feathers is novel. And in this technique, you can alter some parameters to get out different type of material. It is the temperature, pressure, and the duration of the treatment that you can alter. And this makes the feathers more accessible to further use. Okay, so at Rice Processum, we have made initial tests in small scale. You can see the reactor we have used here in the middle picture. It is a 40-liter reactor in batch, and where we found optimal parameters for this treatment of feathers. And at the end, you can see after drying the material, and then you actually have to grind them to get a powder. And the color of the product differ with mainly temperature and how high harsh treatment conditions it is. And also, this steam explosion process was demonstrated in a demo plant in Sweden. So we went from TRL4 to TRL7. And we used this biorefinery demo plant located next to us in Sweden, where we could produce continuously 20 kilos per hour of feathers. And we had a starting material of 500 kilos. This production unit is normally used on wood chips, so this was very novel for them to use this material. So the results from the demo scale show that this actually worked. But since the feathers are much more lightweight than wood, we anticipated some problems when going from the batch to the continuous production. But the feeding screws could actually process the material okay with the operators continuously adjusting the operating parameters. And we were suspecting that it could be some burning in the reactor also, but it was not that bad, so that's very good. And to prevent the dust from the feathers to go around in all of the building, we wetted the feathers before, and it helped a lot. You can see in the picture there where the output from the demo plant, and as you can see, it was wet. We had to add more water than we did in the batch because it has to be pumpable for the continuous process. And we had some challenges in dewatering afterwards since it's a slurry. And those are often pretty hard to dewater. Okay. But to summarize, this steam explosion technique is a technique that doesn't use any chemicals. The energy consumption is fairly low, and it has a high yield and is easy to scale. Okay, and the third technique in this project is the microbial fermentation, which BioExtracts has been working on mainly. And the microbial fermentation is using specific microbials to break down the proteins in the feathers. And this facility is located in the southern Sweden. So here you can see a schematic picture of how the process works. And you start by adding the feathers to the fermenters and then adding water and also media for it to grow to it. And then you sterilize it and add a specific bacteria and also introduce air to the fermenter to help the bacteria break down the keratin. And after this has been working for several hours, then you harvest the fibers, and then the fibers are dried. So here you can see the feathers when it's added before the hydrolysis, and then the fiber broth afterwards. And then the last picture is the dried fibers from the microbial fermentation. And then the production was conducted. At first, it was conducted at small scale to get the right parameters done. And then now it has been tested in 500-liter fermenters, as you can see in the picture. And the fibers that were produced is biodegradable. They are lightweight and non-toxic, water retentive, insulating, effective as a structural reinforcement, and nitrogen rich. And the scaling up of these was successful. To summarize all of these three techniques next to each other, you can see that they have different benefits. The first one, mechanical grinding, is an easy technique because it's not many steps in it, and it's cost effective, but it's pretty high energy consumption. The steam explosion is a scalable technique, and it has the middle energy consumption. And microbial fermentation could be complex to scale, but has very low energy consumption. Thank you.
Thank you, Jonna Tak. Any questions for Jonna?
So thanks very much, Jonna. I see that you are comparing the three different technologies, but then we obtain different products. So I'd like to know a bit what are actually the differences, or how can we compare the different products? What are the properties, or what's the difference actually of getting one product or another through different technologies? Or
So we have tested these things for all of the four products as non-woven geotextiles and hydroponic foams and mulch films, etc. But it showed, I mean, it's different how the properties vary, like the size of the fibers afterwards, or how degradable they are. So some of the techniques were better for each. So I think microbial fermentation was only tested in the long run for hydroponic foams. Steam explosion was for all of the four ones pretty good, and the mechanical grinded material was tested for.
So thank you very much. So next presentation is by Julen Vadillo, coming from Spain, CIDETEC. He's going to be talking on the demonstration of agricultural biodegradable products and presenting some prototypes and the application. You work as research manager at CIDETEC, the coordinator of Unlock, and yes, coordinator of CIDETEC. No, Sarah, of course, I already introduced Sarah. And you are specialized, I believe, on polymer science and on the valorization of biomass and other waste. So thank you very much.
Yeah, that's correct. Thank you for the introduction. So as Vicky said, I'm going to talk about the technical part of the more scientific part. So sorry for the graphs, the tables, the scientific issues, but the presentation is going to be separated into parts. After a brief introduction, I will speak about the effect of the steam explosion into the feathers. And then we are going to see what's happening when we add these feathers into agricultural bioplastics. Okay, Sarah speak very well about the objectives of the project, and Jonah also. Just to remark that we are taking the feathers provided by the drop, we are making some pretreatments to treat the feathers, and then we are going to develop a family of bioplastics that then Lorena is going to talk about them. So I'm going to talk about this arrow that is between the treatment and the products. Okay, talking about the feathers, which is the main actor of this project, only remark that is a big issue in terms of waste management. In figures, it's a problem of about 3.6 million tons. Actually, the valorization waste are actually the incineration, the burying in fields, and also a small part is for animal feed production and development and other material developments. Mentioned that the 90% of the feathers are keratin, which is a protein quite hard to degrade, and the challenge here is to make this difficult degrade material into an easy degradable material. For that purpose, we have the steam explosion or the chemical fermentation. Okay, talking briefly about the keratin structure, I want to remark that we have ordered conformations and disordered conformations. In the first one, we have the alpha helix structure, that is the pink one, and is more related to wool. And the other one is the beta sheet, that is the blue one, and is more related to the feathers. At the end, these ordered structures make the feather difficult to degrade into the soil. Also, we have sulfur brights that are between these ordered structures, and the combination of those things is the thing that make this structure difficult to degrade. So the object here is to decrease both these bonds and the ordered structures in order to enhance the biodegradability. Okay. For that purpose, in this case, we are going to focus into the steam explosion that Jonah has explained very well. Here we have some different feathers treated by steam explosion. You can see in the table at different temperatures for 160 to 190 and different resident time. At the end, when we increase the temperature and the resident time, we increase the severity of the treatment. And as we can see in the picture, we obtain a more dark feathers. At the end, the severer is the treatment, the darker gets the feathers, so they are more treated. Okay, sorry for the tables, the data. I'm going to explain very briefly. Just say that if you're interested into the scientific data, we have published a paper. There you have the reference, but only two things. With the steam explosion, we obtained that the order structures are decreasing successfully. You can see in the second column that we go for 72 to 52%. And then into the other table, we see in the elemental analysis that we have a decrease into the sulfur, that is the S, from 2.3 to 1.8. So we confirm that successfully with the steam explosion process, we disrupt the order structure and we break those bridges. And then we are going to see what's happening to the degradation of the feathers. Here we have the biodegradation of the feathers in the soil. The red curve is the one of the untreated feathers, and the other curves are the one of the treated feathers at different conditions. We see that in general there is a real enhance of the biodegradation coming from a not biodegradable material to a easy biodegradable material. Also, we see an increase into the speed of biodegradation. We see here that the treated feathers degraded quite fast. So we achieved the objective that we were looking for. We obtain a material which is very easy biodegradable in the soil. Additionally, our colleagues for OWS performed a test of how was the effect of the feathers into the soil. And we observed that with low amount of feathers, 0.1 of 0.05, we obtained a fertilizing effect into the soil. So the plants were growing more. with higher percent of feathers, we have a bad effect, but in the case of low amount, we obtain a result similar like a black soil with nutrients. So we have an additional effect of the feathers into the soil. Okay, then we go to the other part, that was the preparation of the agricultural bioplastic. In this part, BioMe, which is the compounder of the project, prepared this big portfolio of different biodegradable matrices, taking into account the final application, mechanical properties, processability, biodegradability, and the objective, in combination with the steam explosion feathers provided by Processum, was to develop some compounds, and from the compounds we will perform different process to prepare the mulch film and the different products of the unlocked product. We also prepare some ribbons for catalyzation. We are going to focus here on the ribbons, and then Lorena will explain about the different products. Okay, we prepare the bioplastic. You can see there the ribbons. We observed that when we add feathers, the color was quite darker because of the feathers. And few remarks of the characterization. Apart of the color, we don't observe any modification on the thermal stability. And the bioplastic containing the feathers were a little bit more rigid, but they don't have an effect into the performance of the material. Okay, just going before the characterization or the degradation, I would like to separate. I think that the slide would change a bit, but I don't mind. We have to make the difference between the disintegration and the biodegradation. There are different concepts. The disintegration is a physical process where the material is falling apart. This is a process that when we have the material, we see how it's degrading into the soil, and then we have the biodegradation, that is the transformation of this material into CO2, water, and biomass. At the end, when we have the bioplastic, we observe in the first part a disintegration of the material, but then when the material is degraded, we have to observe that the whole material is transforming into these things. Okay. In the case of disintegration of the bioplastics, at the end is a physical process, and the mechanism is the one that is in the figure. At the end, the material presents holes when it's surrounded by the feathers, and these holes allow the introduction of humidity. At the end, the humidity makes the material more brittle, and at the end, the material breaks more easily and fall apart more easily. In the column, you can see the results of the disintegration, and we have to say that all materials present a very good disintegration in soil at the end, with the exception of the Unlock 6, that since it has some PLA, the PLA has a lot of problems to degrade in soil. So with the exception of the Unlock 6, the other matrices disintegrate completely. And we observed that with the feathers, the disintegration was more quick. You can see in the low some picture about the effect of the disintegration. Okay, and finally, talking about the biodegradation, we observed that the addition of the feathers did not affect to the biodegradation, because the matrices were almost biodegradable. So with the addition of the feathers, we don't observe a big change. Since we see here the blue and red curves, that they are still biodegradating, because at the end there are very long tests. So for the moment they are biodegradating. In the of the right, the green curve that is unlocked 8, I guess, the biodegradation was very good. And on the case of the pink one, since it's the unlock 6, it has the, at the end, the biodegradation is very bad. So we have to find another solution that could be the industrial composting or other type of treatment. At the end, we have to see, depending of the nature of the polymer, we can have ways to biodegrade the material. finally mention that in this stage of the project, we are actually test to the real field. We have here in Acudam in Spain, there are some testing of the multi-films and the nonwovens, and in Terraquatica are making some trials with the citrates. So as a conclusion, regarding the two sections, mentioned that the steam explosion was successfully used to treat the chicken feathers, and we observed these feathers were less structured, and that leads to a higher and faster biodegradation in soil compared with the non-treated ones. And additionally, we obtain a fertilizing effect, which is an additional good effect to the feathers into the soil. And regarding the bioplastics prepared from the steam explosion feathers, we observe that the disintegration of the bioplastic is accelerated when we add the feathers, and we observe not modification of the biodegradation. So we obtain similar biodegradation rates. So any question, I will be very pleased to answer it.
Thank you, Julian. Thank you. Any questions for Julian? You were too clear.
Okay, thank you.
Thank you. Eskerrik asko. So Julian already introduced Lorena Ruga, who is working at Technopackaging, and you are a chemist and still completing a Master of Quality, Safety and Technologies, and you are advisor at Technopackaging, advising on new products from bioplastics. So thank you very much, Lorena, and the floor is yours.
Thank you very much. I am going to talk about 3 of the products developed in this project. This is the index. I will make a brief introduction about this product, and then I will be fond of it. So within the framework of this product, we have developed 3 products. The first one is the match film developed by Technopackaging. The second one is aerophonic foams developed by Acudam, and the seed tray developed by Acudam. So this material are made by biopolymers developed by BioMe, and the steam explosion feathers developed by Processum. The match films, the final formulation from the match film is the log 1 plus 5% steam explosion. And the technology used to produce this film is the blown extrusion, who requires to melt the material and feed it to a heater barrel with a single screw that you can see in the first photo. Then it enters into a vertical die and gets extruded to form a thin wall tube. Then there is injected to expanding the melting blend, and then it gets pulled outwards to cool down, and the bubble is flattened until collapsed into thin layers. Then it's get towards the wind-up extension, and finally it gets rolled. So this is the characterization of the matching films. We can see that the thickness it doesn't affect significantly. We can see that these maltings are very elastic, and their properties are very optimal. So it can be adapted depending on the crop that you want. We can see that the biodegradation and the biodegradability are also studied in parallel to adapt the characteristics of these maltings to their final application. Until now, it has been seen that due to the speed of the disintegration of this kind of mulchings, is more suitable for short crops as lettuce or broccoli. Currently, a study is being carried out by Acudam and by us on its biodegradability in soil to determine the durability of these mulchings. the second product is hydroponic foams. So a little context, the hydroponics are used in horticulture, and it involves growing plants without soil in an artificial environment. So the substrate generally used are porous media that retain the moisture, the oxygen, and the nutrients, and can providing physical support for plant roots in this system. So the aim of this product is to provide an alternative substrate based on biopolymers, reducing the environmental impact and generate zero waste compared with traditional ones. We also see that the use of keratin fibers enhancing the biodegradability and its own life and providing nutrients to the soils. The technology that we use to produce these kind of farms is the physical forming by extrusion, which involves to inject air as a blowing agent in the process while the pollen is melted. As the material acidifies, the gas expands, creating a foam structure. There you can see that the foam obtained by M+ have a diameter of 1 centimeter, and the porous size is about 1 millimeter. For these foams, we determined that the best formulation is the unlock 1 plus 1% of steam explosion feathers, plus 5% of HCBC, which is a compatible size, who helps to obtain a homogeneous foams. Well, here you can see this chart that shows the physical properties of these foams. They have a low density, the cell size are very lower, the pH is very optimized. Then we have the results of the disintegration test. We can see that after 6 weeks of compounding, the waste generating is minimum. And also the data biodegradation test that shows that these unlock foams enhance the biodegradability due to the presence of the keratin foams. We also did a product validation. In this chart, we can see that the unlock foams, which is the orange ones, has the higher nutrient retention rate. So, and this is a key factor to obtain a higher crop yield. We also see that unlock foams exhibit a great yield comparing with the traditional ones by 20%, which is a very high percentage. Other factor important in these foams are the water absorption and its organic structure due to the keratin fibers that affect positively the unlock foam performance. Finally, we have the seed trays developed by Akudam. In this case, the final formulation is the unlock seed rigid plus 10% steam explosion feathers. The technology used as a thermoforming processes. We consist in heating the seeds until it becomes soft. So after which the mold is applied, so the seed acquires the shape of the mold. Then vacuum is applied to eliminate the air between the mold and the seed, and then you can separate your tray. This material is also made from non-fossil materials. Akudam has carried out some tests and has assessed that is biodegradable in compostable conditions, and this product enhances circularity by turning waste feathers into valuable agricultural products. Here we can see the results of the disintegration of the germination rates with spinach and chili pepper that show that the unlocked material performing the best with germination rates about 90%. This rate allows for precise control over moisture, temperature, and light, creating optimal conditions for germination. We also see that the production and end-of-life phase of unlock contribute to reducing overall the carbon dioxide emissions. Thank you so much. Any questions?
Thank you, Lorena. Any questions for Lorena? Laura has one.
For any of the producers here, but final or the seed trays, the foams. So the first question would be, do they all have? And the second question would be, what's the difference actually between a product that has an amount of feathers and another that has more, a big feathers, or is that something that is relevant, or in the tests, the amount of feathers, what does that?
Well, we can see that the amount of affect the biodegradability. So depending the condition and the end use for this product, it can affect. So when you need a product for a long-term crop, the amount of feathers is lower than for a short one. So it can be depending of the product that you want and it's in use.
Thank you very much, Lorena. Any other question before we go to the last presentation before the coffee break? Thank you. So excuse me, Justina, but I'm going to read this because I want to make sure I pronounce your name properly. So we have Justina Uyatecha from the, sorry, for a Spanish lady, it's not easy, from the biopolymer group at the Luka Siewicz Research Network and Lodz Institute of Technology. You have more than 18 years of experience, research experience, specializing in natural polymer modification, biorefining, and the production of microbial polymers. You have more than 40 scientific articles and 9 patents and patent applications. So thank you very much, and the floor is yours.
Thank you very much. Good afternoon. I'd like to present to you our... Okay. Yes, thank you. Using feathers, it means non-woven obtained by needle punching. First, a brief definition of non-wovens. A non-woven is a type of fabric or material that is produced without knitting or weaving. Unlike traditional textiles, that are made by interlocking yarns. Non-woven fabrics are created by bonding or entangling fibers together through mechanical, chemical, or thermal processes. You can see on the pictures, you can see the differences between these materials. Regarding the manufacturing methods of non-wovens, they are made by processes like felting, needle punching, thermal bonding, or chemical bonding. In our institute, we have possibilities to obtain a few kinds of nonwovens, but we have selected needle punching as the most suitable technique for the manufacture of nonwovens in this project. Needle punching is a physical method of mechanically interlocking fibers webs by using barbed needles to reposition some of the fibers from a horizontal to a vertical orientation. Thousands of needles interlock fibers in a web. Why we decided and selected this method? Because its advantages, it's ecological and versatile method. Ecological because this method is mechanical, does not require the use of water or of chemical substances, and versatile because needle punching machines can process a wide range of fiber, both natural and synthetic. Here you can see some schematic diagram of needle punching nonwoven machine. In a few words, I will describe you steps of the classic basic process and device. So first is former. This unit distributes fibers to create an even layer of nonwoven fabric. It means web. The fibers are precisely arranged to achieve desired thickness and uniformity of the material's structure. Then is carding machine. This unit separates fibers into individual strands, aligns fibers in order direction, which influence the strength and flexibility of the resulting material. The next one is crosslapper. It takes fibers, the web, from a carding machine and spreads them eventually across the entire width of the production line. This ensures a uniform structure of the nonwoven fabric. Here we get a multi-layer structure. And then the most important part, a needle punching machine, and the main element is a moving plate equipped with hundreds or even thousands of needles. These needles perform rapid up and down movements, piercing the nonwoven fabric placed on a special base plate. This process leads to the mechanical entanglement of the fibers, and the final effect depends on the number of needle streaks per minute, as well as an amount of needles. And then product is collected. And I'd like to present needle punch nonwoven technology developed at our institute, highlighting the differences from this base method. And the first difference is that we at first use fiber opener and blender. The role of these units is to fiber losing and fiber blending. Fiber losing because the raw fibers fed into the machine may be compressed or entangled, and the machine separates the fibers, making them easier to process in the next steps. And fiber blending, because fibers from different sources with different properties can be mixed to create a homogeneous fiber mass. We used this equipment because of both reasons. And now that's former carding machine. I told you about this. And something new after carding machine is our original solution. Maybe not, okay, it's good enough for us. This dispensers The dispenser task is to introduce properly prepared feathers by sprinkling them onto single fiber web, coming out for the carding machine. Dosing rolls, ensuring a regulation of a number of feathers added, of amount of feathers added. We can see cross lapper behind the dispenser. The feather laden webs are layered on the top of each other. You can see this on picture, I hope. Using cross lapper, this ensures that the feathers are enclosed within the structure of the nonwoven. Of course, a needle punching machine, needle loom. Our machine consists of a moving plate equipped with less than 2,000 needles. This process leads to the mechanical entanglement of the fibers and feathers. And the last part is a calendar, an additional step in our nonwoven's manufacturing method is the consolidation of the fabric using this unit. Its task is thermal consolidation of nonwoven fabric by heating. Its use is possible thanks to the application fibers from a thermoplastic material, in our case from a biodegradable polymer such as PLA. Additional bonding, the PLA fibers takes place in this unit. This process allows for the enclosed feathers within the structure and improves the strength properties. And a short description of our developed prototype. In order to obtain a biodegradable product, PLA and cotton fibers were used to manufacture the prototypes. Nonwovens were produced using only PLA, all mix PLA cotton as a base. We use pre-treated feathers prepared by our partner Cedrop. They were cleaned and shredded by Cedrop. We tested several shreddings variants and selected the one where the main fraction consists of particles size between 1 to 15 millimeters. As I mentioned earlier, after the needling stage, we apply stabilization through the calendering, and the parameters was temperature circa 150 Celsius degrees and the speed up to 2.5 meters per minute, and the maximum feather content in our nonwovens is 50%. With a higher content, it's become challenging to calendar and achieve a uniform structure. We can obtain these nonwovens with basic weight up to 400 gram per square meter. And we can produce nonwovens 1 meter wide with maximum capacity up to 100 meters per week. And you can see here different structures, and you can see feathers inside this in our product. We conduct biodegradation tests of developed in soil of developed nonwovens. In our accredited laboratory of biodegradation and microbiological research. Full title of this method is determination of the degree of degradation and plastic and textile products under simulated soil conditions on a laboratory scale, method of determining weight loss. It means that the higher, the greater is the weight loss, the better is biodegradation. As you can see, the rate of biodegradation depends on acidity of cotton fibers. Is better where cotton is inside, and also depends on the amount of feathers inside. And pure PLA, not pure, PLA and feathers nonwovens degrade slowly in soil. Such nonwovens can be used for a longer period, even up to several months. These fabrics, these nonwovens, will biodegrade more quickly in composting conditions. On the other hand, nonwovens containing cotton fibers are more suitable for shorter cultivation cycles. You can see still the samples after 6 months, but the basic weight of these samples is much lower after this time. And we also tested whether the biodegradation products of our nonwovens have a negative or maybe neutral impact on the microflora present in the soil where the biodegradation is taking place. It can be observed that in the control soil, after 6 months, control soil, it means without biodegradable material, and in the soil after a biodegradation test, the quantity of microorganisms remains at a similar level. This indicates that the tested material have a neutral effect on the microorganisms. Also, project partner conduct also a field test. The nonwoven were tested for growing lettuce. Lettuce achieve an excellent performance in 5-6 weeks. Nonwoven tissue remains compact after 6 weeks. There isn't any break, and it remains perfect instead strong rains. There are some weeds below nonwoven tissue. However, the harvested lettuce was clean, free of weeds and soil. Summarized advantages of our product: biodegradability. The used nonwovens after the season. Nonwovens after the season can be either remain in the soil. I think about PLA and cotton nonwovens, or be placed in compost. Then they will not end up in a landfill. Possibility control the biodegradation time by choosing the proportion of ingredients. Of course, we used waste feathers, so removal, reuse the feathers. Provision of nutrients for plants, because feathers are a source of nutrients, especially nitrogen. And advantage is possibility of forming seed pots. Pots can be shaped and their form can be fixed through welding. And practical application is an agro-woven fabric for growing vegetables, fruit, flowers. Thank you very much.
Thank you, Justina. Any questions? I guess we all need a coffee break. Thank you so much. Yes, so we will have a coffee break of 15 minutes. Please don't forget that there is a dedicated exhibition area right after the door on the right with the end products of Unlock. And after the coffee break, we have still one session with two leading projects bringing from with ENCO and Ways to Funk, Brilliant, sorry, with ENCO and Ways to Funk with Bio-Based Europe. Then we will look at the highlights from our coordinator, Sarah from CDTech and Unlock. And then we will continue networking, but you can start at the coffee break. Thank you. Okay, slowly we're gonna continue with the last session, as I was saying, with two of the other leading projects, starting with Brilliant. And we have with us Anya Craparo from Enco, sorry, which is a consultancy based in Naples, specialized on impact and exploitation for European collaborative projects. And she's presenting us a brilliant project which is enhancing new business models for rural economy development. It's obviously owned by economy, and well, you are going to be talking on Brilliant, so I'm going to stop here. Thank you very much.
Thank you for the introduction, Vicky, and thank you also to all the organizers of this a networking event, because it's fundamental for the create synergies between all our European funded projects. So I'm very glad to be here to present to all of you our Brilliant project. I will start with a brief presentation of my company, Enco, as a project partner, and then I will go through an overview of the Brilliant general information, the context, and also the main objectives, the concept at the basis of the project, the main challenges, and then, of course, the outcomes that we achieved so far. So, as I said, I'm working for Enco. Enco is an Italian company based in Naples, and we have also an office in Milan, and it has an experience of almost 40 years in managing research and innovation projects. And at this moment, we have completed 21 projects. We have 25 ongoing projects, and between them we are also coordinators. And the programs of the project that we are managing are mainly the Horizon Europe, the Horizon 2020, a partnership, research and innovation in the Mediterranean area, and then the 17 framework of the European Union. And in these projects, the main services that we are providing are related to the innovation management, the project management, also the management of dissemination and communication activities, and also all the activities related to business models and replication, and also sustainability assessment and trainings. And the projects that we are managing are related to different fields, as for example, agri-food, bioeconomy, industry, raw materials, circular economy, health, and blue economy. So we are trying to use our expertise in these different activities and different fields and sectors. So as I said, Enco is partner of Brilliant. And what is Brilliant? Brilliant is a project that aims to support the adoption of sustainable and also cooperative business models inside the rural areas. And especially for our project in 3 pilots in Italy, Spain, and Denmark. We will see after in the coming slides more details about the feedstock, but basically in Italy we have the feedstocks based on cardoon, safflower, and sunflower. In Spain, we have potato rejections and also the processed water. And in Denmark, we have the rapeseed. And the main aim is to to have these sustainable business models and to also encompass a wide range of high value-added byproducts, such as the vegan protein, the additives for different uses, the products for animal feed, the bioplastics, and cosmetic applications. And we are trying with our project to also minimize the environmental negative potentials by setting up and optimizing 10 value chains that are in which are working our pilots. And with Brilliant, we also would like to increase the incomes of the primary producers in these rural areas and try to diversify the incomes. So by, for example, reducing the risks and create, of course, new jobs. And so what about the consortium? The consortium has 13 partners coming from 6 countries, from Spain, Italy, Belgium, Czech Republic, Denmark, and Greece. The project coordinator is CIS, the technological center in Spain, and we have 3 research and technology organizations, 3 small medium enterprises, 3 large companies, which are the main related to the pilots, and we have 2 clusters and 2 associations. And all together we are working on the works of our project that are based on this specific context, because as you probably know, the rural areas cover approximately the 80% of the European territory. And so these areas are very important, and they play a key role in improving the deployment of sustainable bio-based value chains through, of course, different typologies of actions. For example, sustainable food, raw materials, and renewable energies, or reduced fossil fuels dependence, biodiversity preservation. So in this context, that we have at the basis of Brilliant, we have also our motivations to proceed with our project, and mainly they are related to the bio-based value chains that have become very crucial to contribute to the to cope with these challenges in Europe and also worldwide, as for example, you know, the crisis of the materials supply, or the climate changes that are also, for me, that I'm coming from Bologna. On Friday we had very massive floods. It was very a bad situation for the rural areas around the city. So I know that these problems can be quite challenging for a project like Brilliant. And we also want to ensure transition and a fair share of benefits all along the bio-based value chain and actors. And of course, we are trying to be aligned with the Common Agricultural Policy, the Green Deal, and the bioeconomy strategy objectives. And so we are trying to to do our part in these changes. And we are also exploiting the existing opportunities to boost bioeconomy deployment, such the need of raw materials, and also for the biocommodities, and also interesting properties for several applications and markets. So how works Brilliant? Brilliant will implement a multi-actor approach, especially for the validation of a group of 4 main actions for the bio-innovation. And this graph just help you somehow to understand better. So the aim of Brilliant is to set up free cooperative pilots in, as I said, in Italy, Spain, and Denmark, and they are working on 10 value chains. So we have 6 value chains in the Italian pilot, 2 value chains in the Spanish pilot, and 2 in the Danish pilot. And also these value chains, these pilots are working for the validation of the 4 main actions of bio-innovation, especially to try to create robust rural bio-communities, to achieve the circularity and sustainability, and to integrate short supply chains, and to produce value-added bioproducts. We work with several primary producers, and also we have several end users. So it's the structure and the work and the approach in Brilliant is complex in a way, but we are within all these activities, of course, we are trying also to create some business models to be tested for the cooperation in rural areas. And Brilliant has a methodology based on 4 main phases. So, you can see in here there are a lot of activities that all the partners are working and managing, but we start from the phase 1 on the benchmarks with different activities. Then in the phase 2 we have the bio-innovation. In the phase 3 we have the validation of the 10 value chains and the project solutions. And the last phase is more or less related to the exploitation of our results, and also to create the replication of the approach of our project. And of course, we have also optimization toolkit related to our business models, but I won't go. I don't want to go in too many details from the technical point of view. I prefer to just have a look after in the details of each of the pilots and how they are working and the outcomes that we have. Of course, has probably all these projects we are facing some challenges. So we have to address the demonstration of the sustainable supply of bio-based feedstock by setting solid environmental sustainability and circularity criteria for a bio-based system. We are facing also political and legal barriers related to the waste byproducts valorization, also the economic feasibility of bio-based value chains. And we are trying to address the social aspects related to the society and local society, as the consumers' acceptance, the workforce skills, and so on. And also the promotion of some schemes enabling a decrease of the environmental impact. And as I said, considering this context, the structure of our consortium, and also the main concepts, we are also trying to follow, of course, the direction to achieve our outcomes. And so for the impacts at local level, we have the recovery of marginal and unused lands using regenerative agricultural practices. And we are engaging 8 farmers. we also published the first policy bulletin, and the main outcomes coming from this will be extracted and shared with the key stakeholders, especially through the Advisory Board of Farmers. The Advisory Board of Farmers is a group including different relevant key players as farmers, primary producers, clusters, associations, also industrial players and research centers. And we are trying with this board to have discussions with of course, with them to try to get some advices and also best practices, and to give them the word to help us to have the success of the implementation of Brilliant. And we have also the development of 10 multi-contractual agreements between primary producers and industrial actors. And by the end of the project, the idea is to have 30 new jobs in the rural areas. And so, going on a detail of our three pilots here, you can see some differences and some similarities in the three pilots. And for the climate, you can see that we go from the Mediterranean in Italy to the continental in Spain and the oceanic in Denmark. The type of feeds, as I said in the first slides, are more related to the agro feedstock in Italy and Denmark, and to the industrial food waste in the Spanish pilot. For the bioproduct and waste, we will have in Italy the vegetable oil, residual biomass or cake. In Spain, organic waste from the potatoes processing. And in Denmark, the rapeseed cake from rapeseed oil extraction. For the primary producers, we have, in Italy, we have multiple cooperatives and individual farmers because the pilot owners is working with the local cooperatives. In Spain, we have a medium cooperative of farmers, and in Denmark, we have the large cooperative of farmers. And for the biorefinery, we have small-scale ones in first stage and larger facility at the end in Italy. We have the pretreatment facility and the post-processing units in Spain, and we have testing facilities to improve process in Denmark. As for the end use, in Italy, the idea is to have the animal feed, the edible mushroom substrate, bioplastics, biofertilizers. In Spain, the mulch films and the shrink film, and in Denmark, vegan protein and adhesives. So, I wanted just to share the main outcomes for each of these pilots, starting from the Danish pilot. The Danish pilot is managed by 3 of our project partners. DLG is the Danish cooperative of farmers, and also is the provider, the supplier of the feedstock. And we have DTI, who is in charge with the process development of the products. And we have also Kimmer from Greece, who is testing the products and also trying to support the partners in to give close to market feedback. And for the outcomes and also the process, we can say that the protein content reached 45–50%, which can imply around 40% of carbon dioxide emissions avoidance in the process. And the protein-rich powders obtained in pilot trials will be tested in different baking products, considering, of course, different replacement percentages. And we tested the protein for bioadhesive applications, and no synthesis issues were observed at either 20 or 40% phenol substitution levels. And so we think that the strength results are very promising, and wood failure tends to reduce when substitution level increase, but however the performance is satisfying the standard requirements that we have to achieve. And moving from Denmark to Italy, the Italian pilot is managed by, in total, by Novamont, who is working also with local cooperatives and farmers. And the benefits and the effectiveness of the pelargonic acid as a desiccant pre-harvest have been tested with excellent results. And biomass of cardoon produced in during this year is under testing to be valorized for the production of mushrooms ballets. And for the last but not least pilot, we have the Spanish pilot. This pilot is managed by other 3 project partners. We have Paturpat, who is the Spanish cooperative of farmers, and also the industrial owners of the pilot. Then we have ITIP, who is which is a research centers who is testing the products to try to also to give these products to the third partners who is Techno, who will support for the testing of the performance of these products. And so in here, the starch extraction plant is fully operational. And the second batch of starch has been sent for the second set of tests. And the starch obtained has already been successfully tested to produce thermoplastics. And 2 applications are under evaluation, the starch film and the mulching. And then the extraction of starch reduced by 90% of the chemical oxygen demand in the water used in the process, which in turn allows to recirculate the water. So if we take a look on all these 3 pilots, we can say that the Danish one and the Spanish one are fully operational, and the Italian one will be ready by the end of the next summer, so in 2025. They are still working with some tests, and also from the operational point of view is in Italy, it's at this period it's complicated because, as I said, because of the climate changes, and especially because, for example, Novamont is working in the unused lands in the center and the southern Italy. And these areas are, are facing some natural disasters. So this one help the proceed of the activities, but still we are working on that. And of course, all the other partners who are not directly referring to and working with the pilots are working on all the other activities that we have to complete until month 48, because the project with the project we are in month 16, so we have more or less 1 hour and 1 year and a half of works, and we have a lot of works to do in the coming months. We are active on social media. We have also a website dedicated to our project where you can find more other information with more other details, also from the technical side. And you will find also, if you are interested and you are coming from Spain, Denmark, and Italy, if you are interested into be involved in the advisory board of farmers, you will find in the website a section dedicated to this board. You will find some informative presentation and all the information you may need to just evaluate the adherence and the application to our board. I'm not a technical expert really working for the pilots, but I hope with this presentation I tried at least help you to understand a bit about our brilliant project. Thank you.
Thank you, Anya. Very interesting. Any questions? Grazie, thank you. So we go to the next project, which is going to be presented by Estelle Gore, who is coming from Biobase Europe. And you're presenting us Waste to Funk, a project which is aimed to transforming food waste coming from agriculture, restaurants, and the food industry. And I believe you're acquisition coordinator at Biobase and also partner with us with Greennovate in Fulforia project. So we know you. Thank you very much.
All right. I hope you're ready. You're not too asleep and that you will follow correctly the presentation. Don't hesitate to ask questions at the end or during the networking. That way everybody survived the presentation. All right. I will just present briefly what is Biobase Europe Pilot Plant. It's a complex name. It's a not really sexy name, I must confess, but I hope that you will remember now that it's Biobase Europe Pilot Plant, and we are an open access pilot facility for process development, scale up, and custom manufacturing. So basically, we do not own any technology, but we help partners, academics, but also companies to scale up their processes. We are a non-for-profit organization, meaning that we are SME, we do make profit, but it's reinvested in the company. And we are not driven by any academics or universities, and we are not driven by any industrial players behind us. So we are fully independent. We were created in 2008, and now we have more than 180 employees. That's something to remember. And what we like to say is that we are a one-stop shop. We focus definitely on fermentation, gas fermentation, and biocatalysis, because we are an industrial biotech player. It's really our core business. But we help our clients or partners to process any kind of biomass related to compliance of our quality rules towards then biocatalysis, fermentation, and green chemistry, and then purification to the molecules. Because what we see is that our clients or partners are really knowledgeable on fermentation or biocatalysis, but they have no clue how to purify their products of interest. So that's where also we help a lot. And we do collaborate in European projects, but that's not the main revenues that we have. We are really focused on also bilateral projects. It's fully confidential, so I will not be able to talk about it. And that's also why we are participating a lot in European projects as well. It's because that gives us the ability to talk about what we are able to do on the market. And now let's dive into the Waste to Funk part. Why did we build this project? Basically, the call text of the BBIGU, because that was funded by BBIGU, was focusing on valorization of all these parts, which is basically everything except the household food waste, and really relation towards the primary production. So that was really important in the call text, and that's why we built all the value chain based on that. That's really difficult to build a value chain on that. Everybody here said it already. It's scattered, it's not continuously available, there is no guarantee behind. So that was the first problem that we tackled. And why I'm talking about the past, it's because it's almost the end of the project. End of November, it's the end. And we have a lot of good results, so I'm going to show those good results. But from food waste, what to do with that? We focused only on specific things, lactic acid and biosurfactants. I don't know if everybody is aware, but lactic acid and biosurfactants are everywhere in the world, in toothpaste, in shampoo, in paints, in whatever product you use every day, there's surfactants and there is lactic acid. So that's why we said that, okay, there is an impact on Europe, there is an impact for customers, and that's what we will focus on. Also because we had the technology behind, and that we were believing that we could scale it up. And basically the concept was to be built on the classical biorefinery concept. So I hope that you're all familiar with the first part, which is basically valorization of waste through the energy production. That's already something really great that we would like to see everywhere in Europe. But we wanted to push a bit this model to build something also for the farmers to valorize their waste into something that has higher value than energy. And here that was lactic acid and biosurfactants. Here, what you need to remember is that all these names are super great to work with, but also that we build the value chain in Belgium because, as you mentioned, it's really difficult to work with food waste. So we had to be locally present with the technology owner and also with the food waste supply. So that's why you see a lot of concentration of names in Belgium. And as you guessed, the project is built on those three pillars: supply chain, lactic acid, and biosurfactant. On the supply chain, the results are quite promising because out of all the consultation on farmers, people who have a lot of waste from the industry, and from the waste collectors that are already implemented in Belgium, they provide a lot of input, and so Group of the Bake provide this nice website, improved, to collect also smaller batches of waste from farmers. That's one of the biggest challenge in Belgium, is that the farmers need to provide the waste towards Group of the Bake, for instance, or other players. But it costs money, and it's really difficult to build the value chain and build the supply chain and to be reliable. So that's why this website will help Group of the Bake to map out correctly and to reduce the cost also for transportation, because that's driving the cost. On the lactic acid part, again, the valorization towards end product, the project focused on upscaling the technology, so meaning there was no more development. There was really, okay, the focus of producing enough to go to prototype phase. And that was quite successful with the building of a pilot plant in Antwerp. It was co-located to the Group of the Bake, so that's an indication that the supply chain needs to be really set in stone to make it work. And we had a lot of products realized, and Triple W was quite happy with the production phase. Same for biosurfactant, same logic, different players because it's a different technology, but basically it's same loop, pre-treatment, purification, and then formulation. Every time formulation was with EcoVer, and I will see that, I will show you that there is some nice stuff on the market. Just some pictures, because I guess you're all interested with like what's happening to the waste. Basically, it's optimization of this pre-treatment to provide enough sugars for the fermentations. It's all IP of the both technology owner, but if you're interested, don't hesitate to take contact with them because definitely it's working. And for the biosurfactant, we made a lot of trial again, and yeah, basically what I can say is that we realized pilot scale on both lines, so that was quite an achievement. And EcoVer produced a first kind of product market, so really prototyping, small units, but it's already on the market. So that's something that works. So that's quite an improvement. And you can find more information on the EcoVer website if you want. I just hope that the video will work. I don't know if... No, it doesn't work. Ah, it's working. Cannot play media. Yeah, yeah.
Today we are going to discuss about strings. What are the strings? So basically, as I earlier said, you can create a string here also. Again, you don't want to declare anything.
Once
For
upon a
example, I can say
time, in a world
name.
not so different from ours, lunchboxes, drinking bottles, shampoo, and yes, even in your toothpaste. But my little friends at the time came to realize that we can do better.
Why?
Ah, great question, little hero. You see, crude oil is an amazing resource, but not very kind to our planet. That's why we've embarked on the new adventure, using rather unexpected resources, such as food waste. In the enchanted lands of waste to funk, we use the magical conversion technologies of Amphistar and Triple W to turn food waste into extraordinary things, like biosurfactants for cleaning products and personal care, or lactic acid for plastic packaging material.
No way!
Yes, way. Now, let me take you on a journey to discover how we did it. Ready? Our adventure begins with preparing a feast for our tiny superheroes called microbes. We take leftover food, cut it into little pieces, and mix it with water. Then, we let the enzymes do their magic. Time for a pre-conversion quality check to ensure our microbes will love their meal. Guess what? Approved! Our tasty broth is ready for fermentation. We transfer the pre-treated food waste into large fermentation vessels. Now it's time for the real heroes to shine. Microbes.
Are those the superheroes?
Yep. Like the yeast of Amphistar and the bacteria of Triple W, our microbes start eating and multiplying. And then all together start working their magic, producing tons of amazing biochemicals. When the spell is over, the vessel contains our precious biochemicals that we need to filter out before we can move on. So, my little heroes, buckle up now for a new era, from waste to wonders. Time now to hand over the purified biochemicals to powerful wizards that use them to produce sustainable cleaning products like Ecover, or to make toys, lunchboxes, shampoo, drinking bottles, and yes, even toothpaste. The technology is ready. Are we? The end? Oh no, my friends. This is only the beginning.
I just wanted to show you this video because I think the bioeconomy needs those kind of storytelling, and that we need to work on that to make it appealing also for the customers, because one of the biggest challenge that we saw was that working with waste was not that nice for customers, and now with our work we hope that at least that brings the message out that it's possible, but also that it's nice. And yeah, it's almost the end, but it's only the beginning. So basically, the pictures doesn't show, but it ends this year. But thanks to the CBEGU program, there is 2 continuation projects. One with Amphistar, so Surf's Up, and one with Cycle, flagship of WWW. So it means that it's coming again to the next stage. So it's quite nice story. And for instance, Cycle flagship is going to the scale of pre-commercialization. So that's quite the adventure, but quite nice story to tell. So that's it for me.
Thank you so much. Very interesting. Wait, there are any questions for Giselle? That was really nice. Thank you very much. Okay, so we go now to our last session with the highlights of Unlock project by Sarah, our wonderful coordinator, and thank you for the great work you've been doing all these years, and still you have to do the next 6 months. Thank you.
Thank you, Vicky. Well, just to conclude this part of the event, I would like to highlight some relevant aspects of Unlock that the different speakers have shown us this afternoon. So through the different sessions, we have seen how the Unlock project has paved the way for the establishment of a feather-based bioeconomy. So as Daniel Tras has shown, the starting point has been the in-depth analysis of the poultry sector in Europe. Once the current waste management practices were analyzed, the hurdles to the creation of the new value chains were identified, and specific solutions were proposed, including the Unlock case studies. The next step, presented by Jonah Almqvist, has been the scaling up of the further treatments. Unlock proposes 3 different technologies for these further treatments, depending on the final application. These technologies are the mechanical grinding, the microbial fermentation, and the steam explosion. All of them has been scaled up, and their feasibility has been proven at demonstration scale. Demo plants are located in Poland for the mechanical grinding, and in Sweden for the steam explosion and microbial fermentation. Another key part of Unlock, presented by Julen Badillo, has been the development of bioplastic formulation with feather, that is to say, blends of treated feathers with different biodegradable plastics. And the incorporation of treated feathers in this blend has enabled a fast disintegration and biodegradation of the materials. We know now that treated feathers biodegrades much faster than untreated feather, and in a comparable way to cellulose. Lorena Arrua and Justina Vietecha presented how this advantage of faster biodegradation and disintegration has been used to produce a range of products for the agricultural sector, such as mulch films, seed trays, hydroponic foams, and non-woven geotextiles. These products are specifically designed for each of the applications of Unlock, and apart from including a valorized waste that generates a functionality in the product, they provide an input of nitrogen to soil coming from feathers. These products are being validated by testing their biodegradability under different environments, as well as tested in field in real using conditions. Finally, I would also like to thank the speakers of the 2 invited projects to the event for their participation, as well as Innovate for the organization of the event. We can continue the discussion in the adjoining room, where we have prepared an exhibition of products and technologies of Unlock, and well, you have also some brochures with the main results of the project so far. Thank you very much to everybody for coming, and thank you Greennovate for the organization.
Thank you so much, Sarah. Thank you especially to Laura, who is the project manager in Greennovate for Unlock, and for the rest of the team for all the support. Paraphrasing Giselle, this is just the beginning, so I hope everybody goes back home with a lot of learnings. I think we all do. And last chance to see the end products of Unlock when you come out, and we still can network and discuss all these learnings outside. And for the members of the consortium, please remember that we have a dinner tonight at 8 o'clock in Vincent restaurant in the center, in the old part of Brussels. If you don't have the address, please come to us and we will give you again. Thank you very much and see you soon.